Wonderful day, everyone! For this week's episode, we will show the solution for this specific SYNThink problem. The English alphabet has 26 letters, of which 5 are vowels. How many 8-letter words with all the letters distinct can be formed that start with K, have L as the fifth letter, and end with the letter E, and also have exactly 3 vowels? The words of the problem are just strings of the letters and does not need to have any linguistic meaning. So, to solve this problem, we will involve the fundamental principle of counting alongside the use of permutations and combinations. But first, let us discuss the conditions. The conditions are they must have exactly 3 vowels, all letters must be distinct, and finally, the 8-letter word must have K as its first letter, L as its fifth letter, and E as its final letter. So let's get to solving, shall we? First, let us determine how many ways we can choose the remaining vowels to fulfill the first condition. We know that we can only now choose 2 vowels out of the remaining 4, given that all letters are distinct, so it must be without replacement. But we must also take note that the arrangement of the vowels chosen also matters, as in the case of choosing A, B is not the same as B, A. Therefore, we can use permutations to select and arrange our vowels. Our solution will be 4p2 is equal to 12, given that we select and arrange 2 vowels out of the remaining 4. And our remaining vowels are A, I, O, and U. Next, we will decide on how we can try to choose our positions for the vowel. This can be done via combinations once again, as we are given 5 remaining positions left, and let us choose now the 2 remaining arbitrary positions to be chosen amongst the remaining 5. This can be done using 5 combination 2, or you can also say it as 5 choose 2, which is equal to 10. Next, we will have our consonants. Out of the remaining 21 letters, 19 of which are consonants, and the remaining consonants are also displayed on the screen. We will now select our consonants and arrange them in the 3 remaining positions. Given from the 3 initial conditions, the 2 are selected from the vowels. Since we are to select and arrange, permutations are once again necessary. From 19 consonants, we will select and arrange 3 of them, giving us 19 permutation 3, which is equal to 5,813. The reason why we chose permutations because it lets us select 19 consonants and arrange 3. Now, you may also ask, why didn't we use combinations for this matter? Well, that's because we cannot arbitrarily choose the proper arrangement for the consonants. For example, if we chose D, K, and P as our consonant, if we were not to use the permutations instead of combinations, it would also mean that P, D, K would mean the same arrangement as our previous choice. So that's why permutation is necessary. Now, for the next step, we may also omit this step. However, for the sake of clarity, we will still proceed with it. Out of the remaining 3 positions, we are to choose 3 of them. As it suggests, this is only redundant as you only have one possibility which is justified by the combination 3 choose 3, which is also equal to 1. So you can choose to omit this step out because from the previous slide, we already know that the arrangement from the vowels have also chosen 2 positions, so the remaining position is now only 3. And we have also selected and arranged 3 consonants. That is why no matter what the position of the consonants are or what the arrangements are given to the permutation that we have done earlier, it will only result in the same arrangement. That's why it's not necessary to choose to do this combination any further. But we won't involve them in this step because for the sake of clarity and to avoid any confusion. Now, after the arrangement of the consonants, we can now use the fundamental principle of counting to get our final answer. So, following the said FPC, we are to multiply all our possible arrangements and selections to get our final answer, which is 4 permutation 2, 5 combination 2, 19 permutation 3, and finally 3 combination 3. But as said earlier, this is just only equal to 1, so we may omit this factor, which is just equal to 12 times 10 times 5,814, which is also equal to 697, 680. Therefore, there are 697, 680 ways to form 8-letter words given from the initial conditions. Now for our bonus question. Given our previously mentioned clue that is in the problem itself, we can go back here into the first slide. We can see that it takes up 8 letters to form the name. So it's more of like a trial and error because this bonus question is actually easier than the previous problem since it does not need to involve the use of combinations or permutations because we're only blindly guessing what the name of the crush is, right? So given the given the 8 letters that we don't know, and given that the name is composed of the alphabet, English alphabet, we can say that 26 letters is composed from the first to the final position. Therefore, we can just say it as 26 times 26 times 26 and so on until the 8th position. Or you can also say it as 26 raised to 8, which is just equal to this number. So it's pretty large. It's around 208,827,064,576 ways to properly get all the possible 8-letter names. So since given this information, there's only one name that we're supposed to get, right? One name, one unique name, all over the total possible names, just equal to 1 over our previous answer. Just equal to is roughly around 4.79 times 10 raised to negative 12%. So if you have any other questions, feel free to reach out to any of these contacts, and thank you for watching SYNThink. We hope to see you again, and kindly keep posted about our next problem, whether to our Facebook channels or to the syntax group. Thank you.